1. Introduction. Refined Web is a massive web-only dataset comprising 5 trillion tokens designed for training large language models with up to 200 billion parameters. Developed using the Macrodata Refinement (MDR) pipeline, it incorporates content extraction, rigorous filtering, and extensive deduplication techniques on common crawl web data. The objective is to create a top-tier web dataset that rivals or surpasses models trained on meticulously curated corpora like the Pile, exclusively utilizing web data. This dataset represents an advancement in English pre-training datasets for large language models by combining meticulous filtering with strict deduplication on an unprecedented scale. 2. Macrodata Refinement and Refined Web (MDR). Macrodata Refinement is a pipeline designed to filter and deduplicate web data from Common Crawl at a large scale, ultimately producing refined web. It operates based on specific design principles. Scale first. MDR aims to generate datasets for training models with 40 to 200 billion parameters, necessitating trillions of tokens. Strict deduplication. MDR employs both exact and fuzzy deduplication methods with strict settings, resulting in higher removal rates compared to other approaches. Neutral filtering. ML-based filtering beyond language identification is avoided to prevent introducing biases. Simple rules and heuristics are applied, along with URL filtering for adult content. 3. Experiments. Evaluation is based on the popular Eleuther AI evaluation harness, allowing evaluation across a wide range of tasks in the zero-shot setting. Small was built for internal ablations, based on tasks with consistent performance at a small scale. Core is based on tasks commonly reported for public suites of models. Main is based on tasks from the GPT-3 and Palm paper. Ext is based on tasks used by the Big Science Architecture and Scaling Group. For all reported results, plus is used to denote results obtained in an arbitrary evaluation setup, and is used to denote results obtained using the EAI harness, which is also employed for all our models. Autoregressive decoder-only models with 1B, 3B, and 7B parameters are trained based on configurations and hyperparameters similar to those of GPT-3, with the main divergence being the use of alibi and flash attention. 4. Findings. Can web data alone outperform curated corpora? Challenging existing beliefs on data quality and LLMs. Models trained on adequately filtered and deduplicated web data alone can match the performance of models trained on curated data. Average accuracy in zero-shot on the small ag aggregate. All models were trained with identical architectures and pre-training hyperparameters. OSCAR 22.01 underperforms other datasets significantly, perhaps because deduplication is only optional. C4 is a strong baseline, with OSCAR 21.09 lagging slightly behind. Refined Web outperforms both web datasets and the most popular curated dataset, the Pile. Both filtering and deduplication contribute significantly to improving zero-shot performance. 5. Findings. Zero-shot performance on main ag task aggregate. At equivalent compute budgets, Vulkan models significantly outperform publicly available models trained on the Pile and match the performance of the GPT-3 models when tested within our evaluation setup. Zero-shot performance averaged on Core Ag left and XAG right task aggregates. Existing open models fail to match the performance of the original GPT-3 series left. However, models trained on Refined Web significantly outperform models trained on the Pile, including our direct comparison model, right, ruling out our pre-training setup as the main source of increased performance. In fact, Refined Web models even match the performance of the GPT-3 models. 6. Do other corpora benefit from MDR? By processing C4 through MDR, we are able to obtain subsets of data which might slightly outperform refined web. This combines both the stringent filtering of C4, e.g., strict NSFW word block list, 3-sentence span deduplication, with our own filters and deduplication. While such a combination results in rejection rates that would be unacceptable for our target of 3 to 6 trillion tokens, this represents an interesting perspective for shorter runs, which may be able to extract extremely high-quality subsets from large web datasets. While filtering heuristics may require source-dependent tuning, stringent deduplication improves zero-shot performance across datasets consistently. Due to limitations in our pipeline, we cannot apply the deduplication stage independently for refined web. 7. Limitations. The analysis of refined web's toxicity found it to be comparable to the pile in terms of rudeness or disrespectfulness, as defined by the Perspective API. However, this definition does not cover social biases or harmfulness. Further research is encouraged to explore these aspects quantitatively. Using multiple epochs for creating large pre-training datasets raises questions about model sensitivity and trade-offs in the data-constrained regime. Recent studies suggest that models with over 100 billion parameters may be sensitive to even a few epochs. Further investigation is needed to understand the impact of deduplication on sustaining more epochs and the trade-offs between multiple epochs on higher quality data versus a single epoch on lower quality data. Previous research has found limited impacts on zero-shot performance from deduplicating datasets like the pile. However, further exploration of deduplication in curated corpora and its effects in the data-constrained regime is encouraged. These topics are discussed further in the appendices for additional insights. 8. Dataset analysis. The large-scale and diverse nature of web corpora make them difficult to document an analysis as a whole. We provide some key metrics in the section, focusing on document lengths and a breakdown of the top domain names. We also refer to the analysis of the distribution of toxic content presented, makeup of refined web in document lengths, left, and top domains, right. A. We find the OSCAR datasets and RW-RAW to have similar document length distributions. Following filtering, most of the short documents are discarded from RW filtered. As deduplication removes spans, it reintroduces shorter documents to refined web. We note the makeup of C4 and refined web to be relatively similar, with a longer tail of short documents for refined web. Finally, the pile exhibit a unique makeup, with a long tail of both long books, etc., and short documents. B. Top domains in refined web span from popular content platforms, Blogspot, WordPress, Tumblr, etc., to news websites, CNN, New York Times, etc., and include also technical content such as Biomed Central or Springer. 9. Multilingual refined web multilingual data. Using the language identification filter, we classify processed Common Crawl data into 176 languages. Processing multilingual data. The MDR pipeline can be used to process all languages. Features such as text extraction are language agnostic, whereas specific filters such as line-wise corrections need to typically be tuned for each individual language. 10. Conclusion. In conclusion, the rigorous filtering and deduplication processes employed in creating the 5 trillion token web-only dataset, refined web, have led to a resource that can generate models competitive with state-of-the-art SOTA models. Refined web has demonstrated the potential to outperform large language models, LLMs, trained on curated corpora. This highlights the effectiveness of stringent data processing techniques in producing high-quality data sets for language model training.